I think there is a driving model that have all the videos of the class.
On Moodle. Yes, Lunita. Thank you. I appreciate it, Luna. Thank you. You are correct. You just go to Moodle. Again, just in case you didn't know. Go to Moodle, right? Where is it? 9C, right? And right here, videos of the meet. There it is, videos of the meet. There it is, right? You just click there, and it is gonna take you to, well, a document with all the links for the videos. All right. Okay, so no, what is it? No. Here, all right. So today's topic, right? We started this topic the previous class. We were looking at how to convert from rectangular coordinates to polar coordinates, right? I give you rectangular, you give me polar back. That's it. That is what we're trying to do. And we began by doing this little example. As usual, we are going to plot every single point before jumping into the formulas. And that is even more recommended, necessary in this process. I'm going to show you why. All right, we did this example, remember? I gave you this point, 0.3. If we plot it, 0.3 will be there, right? I gave you this example. Can anybody please in the chat, can anybody tell me what will be the polar coordinates of this one? Again, we did it already, so if you are copying, you have it in your notebook already. Tefa, thank you. Anybody else? Valerie, all right. Is nobody else paying attention today? What's going on? Thank you, Danny. Nobody else? Danny Ruiz and Danny Diaz, thank you. All right. I feel like maybe you guys are too sleepy today. Maybe that's what's going on. I ask you to please turn the camera on and you don't have it on. Not all of you. Danny has it on. Tefa Cabrera has it on. Not all of you, right? Thank you, Danny Ruiz. Thank you, Lunita. I appreciate it. Bianca, thank you. Not only that, but I ask you to turn this, to change this from rectangular to polar, which is something we already did. So you have it in your notebook, which makes me think you guys are not copying this stuff. You guys are not copying this. Huh? Which makes me think maybe I should ask for your notebooks. Of course, you cannot give them to me personally, but you can take pictures, right? You can take picture of your notes daily. Guys, here's the question. Is that what you want me to do? Should I just ask all of you to send daily to my email the pictures of the notes that you are taking? There are a couple of people who are actually writing in the chat the answer. Tefa Cabrera, Valerie, Danny Ruiz, Danny Diaz, Santi Camacho, and Daniel Osorio. What happens with the rest? Lunita?
Mister, what happens if I copy the final graph of the solution? I don't copy the graph of the step 1 and 2. So I don't have the first graph that show us on the PowerPoint.
Oh, okay, what? You only copy this? What? You only
No,
copy what?
the final graph. The final graph.
Okay, so cool. If you have the final graph, that's great. Cool. You didn't, yeah, we did a lot of other exercises, but you don't have to copy them all. You just need one or two. But we did this, right? We did this. Thank you, Juan Esteban. All right. Thank you. All right, guys, listen. I'm gonna say that this happened because you guys were sleepy, right? We just came from the weekend, so you know, sometimes you don't want to have math, you don't want to have any class. That's okay. I'm gonna say that is the reason. All right, but guys, believe me, if this continue happening, I'm gonna ask you to do things. That's gonna be a grade. You guys are not gonna like it. I am not gonna like it. All right. Cool. But remember, if I ask you to do something, do it, please. All right. So this is how you do it for the people who were not paying attention or who didn't copy this in the notebook. Copy it, please. From here, after you copy, after you plot the point, 0.3, right? You try to determine the distance r. Remember, r is the radius, and radius is this measurement, the line from 0 to our point. In this case, you can see 1, 2, and 3. That is the measure. The measure of r is 3. 1, 2, and 3. So we know r equals 3, right? We know r equals 3. From there, we try to find or determine the angle theta. Remember, the angle is this one over here. That makes 90 degrees. So now we know theta is 90 degrees. From here, we just write this as the solution. 3,90 degrees. I gave you rectangular coordinates and I ask you to find polar coordinates right there. That's it. Everybody, please copy this down. Write this exercise in their notebook, in your notebooks. This is the solution right there. This is the process. All right. This happens only when the point is located in an axis, right? We can look at the answer. We don't have to calculate with mathematics. We don't need to find to take out the calculator. We don't need to do nothing else but looking at the drawing. That's it. This is pretty simple. When a point is not in an axis, that's where things get a little bit more interesting. Take a look at this exercise. From here, we're gonna do the point 2, -2. 2, -2, right? First step, we are going to plot it. So this is 2 in x and -2 in y. There. 2, -2. This is the point we are going to change to polar. Look at this. The point is not on an axis. It is in a quadrant, right? Remember the quadrants? This is quadrant 1, 2, 3, and 4, right? The point is in quadrant 4. And when points are not in the axes, but in the quadrants, things get a little bit more interesting. We need to use some formulas. All right. We're going to begin by determining the distance, r. Remember, r is, again, the line from 0, the origin, to our point. So that is the line r. And we want to find the measurement of this r. Right? How are we going to do that? With this formula over here. This is the formula for distance. You take out this formula from applying the Pythagoras theorem to this triangle. If you apply the Pythagoras theorem to this triangle, you see that this r equals this little formula over here. The square root of x squared plus y squared. Go ahead and write this down somewhere, please. This formula, you guys are going to use it every single time we talk about the distance between 2 points. That's not only for math. That is also for physics. That is also for physics. If, I don't know, maybe in chemistry or biology, you happen to need to find the distance between 2 points, then you're going to use this formula.
Teacher.
Yes.
What was the step 1?
Plot the point, brother.
Okay.
Step 1, plot the point. So you just plot it in the Cartesian plane. That's it. Plot it.
Thank you, teacher.
All right. Also, this distance is not only for this topic. Maybe when you guys are in 10th grade, maybe I ask you to find the distance between 2 points. All right, this is how you use it. This is how you do it with this little formula over here. Write it down, please. Write it down. All right, so how do we use this formula? It's pretty simple, actually. All we have to do is change the values of x and y for the values of x and y of the coordinates. Remember, these are coordinates, right? So the x equals 2 and the y equals negative 2. X equals 2, y equals negative 2, right? If we replace the values in the formula, this is what we get. R equals the square root of 2 to the 2, right? 2 to the second, plus negative 2 to the second. Notice how this negative 2 is in parentheses. Every time, guys, you need to replace, a negative value, put it in parentheses. Otherwise, if you don't do that, the calculator will give you mistakes. You will have mistakes. Don't be lazy. Put it in parentheses. From here, 2 to the second is 4 plus negative 2 to the second, which is also 4. So 4 plus 4. This is 8, right? Square root of 8. We can round this. We can simplify this. If we simplify, we have 2 square root of 2. This is the simplification. This is the simplification, right? But we can round it, just like Lunita was saying. And Tefa wrote in the chat. This is the simplification, but we can round this. Remember, rounding is not perfect, but it gives us some ideas. Tefa is saying that this is 2.83. 2.83, right? Let me show you here. So you could write it like this. Here. Round to 2.8. Let's just leave it at 2.8. Right? This is okay. This is okay. This is okay. You can leave any of these three as your final answer during a quiz. Any of these three are okay. Are you lazy and you don't want to work? Leave this one. Are you good in mathematics and you don't have a calculator? Leave this one. Do you feel like you need to do something else or the teacher is going to give you a bad grade? Take out the calculator and do this one. Any of the three is going to be good, all right? Any of the three is going to be okay. All right, let's continue with this. So congratulations, we have the value of r. Again, we have the value of r is right here, 2 square root of 2. Again, you can round this. This is around 2.8. Now, we need to find the value of theta, right? We are looking for polar coordinates. So we have the r. Now we need the angle. All right, the angle. The angle is this one, right? The angle is this one, theta. Of course, you could also say that the angle is this one over here. Just for the people who are noticing, you could also say that this is the real angle. All the way here. This is the real theta. Yes. But notice how this is positive and this one is negative. Right? Because of the direction of the angle. This one is counterclockwise, so positive. This one is clockwise, so negative. Any of those is going to be good. Any of those work. It is just a matter of knowing which one you want to choose. I'm going to do it with the negative, just because I like it. You can do it with the positive if that is what you wish. All right, from here, to determine the angle theta, take a look at this. We need to use a different formula. This might be new to you. We're going to begin by remembering what is the tangent of an angle. Tangent. Okay, according to SOHCAHTOA, right? The TOA, right, is the part of the tangent. And it is TOA because you have tangent equals opposite over adjacent, right? TOA. Opposite, adjacent, right? Okay, in this triangle, let me erase this. Let me erase all of this. In this triangle, take a look at my triangle. Here, here, and here. If this is the angle theta, this is the hypotenuse, right? What is the opposite to theta? All right, the opposite to theta is this one. Which one is the adjacent? Okay, well, the adjacent is this one, right? So if we were to do the tangent of theta will be the opposite over the adjacent side, right? All right. But here comes a problem. The opposite side is this measurement here. That is awful, sorry. This measurement. That is the opposite, which is this one as well, from here to there. And this value is the value y, because these are the coordinates in y. Same with the adjacent. This is the adjacent side. And these are the coordinates for x. In other words, this tangent is y over x. Opposite, which is y, over x, over adjacent, which is x. This is what I have here. Tangent of theta equals y over x. So we're going to use that formula. But we don't want to find the tangent of theta. We want to find theta alone. In other words, we need to take out that tangent. Eliminate it. Erase it from there. We don't care about the tan. We just care about the angle.
Well, teacher, we don't necessarily need to erase it. We can move it to the other side of the equation.
Yes. Excellent, Danny. Beautiful. But the question is now, how do we move it? Huh? How do we move it? It's pretty simple. We're just going to take advantage of the tangent, the inverse tangent. This is one of the trigonometric functions, but it's just inverse. Look, to find theta, all you have to do is find the inverse tangent. This is how you read it. Inverse tangent of y over x. Some other books call it the arcotangent, the arc tangent of y over x. En español, la tangente inversa de y sobre x. O, de nuevo, en algunos libros la conocen como arco tangente. Este negativo 1, este exponente negativo 1, es como si yo lo leyera como arco, un arco. Pues aquí dice arco tangente. Podríamos tener seno a la negativo 1. Y eso se leería arco, seno, arco, seno. Podríamos tener coseno a la negativo 1. Y eso se leería arco, coseno. Así con todas las trigonométricas. Arco secante, arco cosecante, arco cotangente. All of these are the inverse. And what these are going to give us is the angle alone. What these are going to give us is the angle alone. This is how we do it. Let's take a first look at how do you replace the values, and then how do you do it with the calculator. Let me see if I have my calculator around here somewhere. Here it is. All right. All right, so this is the first step. You want to change the values of y and x. The question is, but what values? Well, these ones over here, 2 and negative 2. Remember, 2 is the value for x. These are coordinates x and y, right? So this is x and this is y. 2 for x, negative 2 for y. Remember the order. This is y over x. If you do it as x over y, you're going to have mistakes. You put this in a calculator and you have your results. The problem is, teacher, I don't know how to use that in the calculator. How do I write the tangent negative 1? How? Here is how. Take a look. Hopefully you guys have your calculator with you, right? Lenita is correct. Thank you, Lenita. All right, hopefully you guys your calculator. Stefan, maybe your calculator is in radians, right? Take a look at that. Maybe that's the issue. All right. Notice how here are the three trigonometric keys. Sine, cosine, tangent. Can you see them? Sine, cosine, and tangent. Thank you, Salome. I can see you knocking. Thank you. But we don't want tangent. We want tangent -1. We want the inverse of tangent. And look at that. That is exactly what we have in blue on top of the key tangent. It is right there. So how do we do it? Simple. Second tangent. If we do second tangent, we are going to have tangent -1, the inverse of tangent. From here, we just write down the information. So we have -2/2. So -2 divided by 2. Close the parentheses and press enter. That's it. -45. If you didn't have -45, that is because your calculator might be on radians. I have it in degrees because I want to see this in degrees. It is not a mistake to have it in radians. But you just need to recognize which is which, right? Which is which. To do that, remember, all you have to do is go to mode. If you go to mode, right there, you can find the piece of information for angles, radians or degrees. If you want your calculator to be in degrees, you just click it in degrees. You just leave it there. But if you like radians, you just do it in radians. You just press enter and that's it. Look, if I do this exercise again in radians, this is the result. -2 divided by 2. Close and enter. This is the result now. Tangent to the -1, so inverse tangent of -2/2 is going to be -0.8. -0.8, just like Tefa was saying. This is not a mistake. These answers both are correct. Just that this one is in degrees and this one is in radians. Now, I prefer radians. I prefer radians. I'm sorry, I prefer degrees. I prefer degrees. So I'm going to stick with -45 degrees. All right? So here it is. Tangent equals -45 degrees. Remember how we said at the beginning that this angle were going to be negative? Because we were looking at it downwards? That is what we said, right? We said that this angle was negative. Because this is clockwise. And look at that. It gave us negative. So we are doing things okay. We are doing things fine. Theta equals -45 degrees. All right? How do you write the answer? The answer, simple. You know that r equals 2 square root of 2 and theta equals -45. So you just put it in parentheses. We are looking for coordinates, so we want r, comma, theta, and all of that in parentheses. There's also another way. You could also say that these are the coordinates. Remember, parentheses, parentheses. You could also say that this is 2.8, and again here, -45 degrees. Why is this correct? Because I said at the beginning that you could round. This is a rounding from here to there, right? Looks like a 22. This number is rounded from 2 square root of 2. You can do that. That is okay. You can do that. All right? Cool. So this is a good answer as well. All right. Beautiful. We know now how to do it. Let's take a look at this example now. Let's take a look at this example. We're going to find the coordinates of this point. This point is in rectangular coordinates. Look. Rectangular coordinates are -1, comma, negative square root of 3. So now you might be thinking, but teacher, I don't know. I hate roots. I don't know how to plot that point. The first step is plotting the point, right? That is the first step. We want to plot the point, right? And you might be thinking, no, I don't know. Just, guys, step back, breathe a little bit. And we can change roots to decimals, right? We can change roots to decimals. All we have to do is round this root. That's all we have to do. Here, this is a drawing for roots. This is a drawing for this point. All right? This is a drawing for this point. In here, I don't have the scale. I don't have the scale. Look at this. This is pretty simple. This point over here makes it so that here we have the x coordinate, right? And the x coordinate was -1, so this is -1, right? And this one over here is the y coordinate, which is negative square root of 3. Can anybody say how much is this, please, in the calculator? Round to what? Negative square root of 3. How much is that? Nobody? Thank you, Tefa. This is negative 1.7. All right, so here, look at that. Here is the point negative 1.7. All right. This is a Cartesian plane, right? I just decided to not do the scale. But this is how you plot it. Okay, so first step, plot the point. Now, we notice that the point is in quadrant 1, 2, 3. Point is in quadrant 3. Now, why is that important? You will see in a minute, you will see why I told you to plot the point first. You will see. All right, let's use our formulas to find the r and the theta. Let's use our formulas. All right, so here, remember, we have the first one, formula for distance. We're going to take the formula and replace the values. X is -1, so we put -1 in parentheses, then to the second power. Plus, y is negative square root of 3. So we put this in parentheses, negative square root of 3 to the second power. All right? From here, just put this in the calculator, and you will see that this is the square root of 4. Ooh. How much is the square root of 4? Well, that is 2. That is 2. So now we know that r equals 2. Now we know r equals 2. This part over here. The measurement of this line, this segment, this little piece is 2. Pretty good, Tefa. All right. What do we do now? Remember, we are finding r and theta. So now we have r with the usual formula. This didn't change. This is the thing that we already practiced in the past exercise. So we're going to do the same with theta. To find theta, we're going to do the same formula. Look, theta equals tangent to the -1 of y over x. But before all of you jump into your calculator, I want to see you guessing. That's right. I want you to guess how much is theta. Take a look at the drawing and tell me a number that you think that is the value of theta. Now, don't get scared. Don't be afraid. I am not going to read every single one of the answers. I am not going to say, hey, no, you know what, Tefa, you are wrong. No, I'm not going to say that. Hey, Danny, no, you did it wrong. I am not going to say that. I am not going to say that. I'm just going to ask you to write how much you think is theta. That's it. Do you think theta is 45 degrees, 30 degrees, 100, 200, 400? Write it in the chat, please. Tell me, how much do you think is theta? Everybody, please. We only have 3 people so far in the chat. Try to don't copy. You're not going to gain anything. If you see an answer and you copy, you're not going to gain anything. I'm not going to give you points for this. Just write what you feel it is. Just write. Just write what you think is the answer. You know, I think this could be 700 degrees. Okay, then go ahead and write it. It's okay. All right, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19 people. All right, let's wrap it there. All right, 19 people answer. Beautiful. So So all of you, nah, not all of you, but a lot of you said this angle is 200, 220, 240, something like that, right? More than 200. It looks like for you, it looks like this number, this angle is between 200 and 250, right? Some are saying 215, 230. All right, cool. 240, cool, beautiful. We also have some other answers a little bit lower, and some other answers a little bit greater than that. It's okay. Most of you are saying this angle is 200 and something. Well, it makes sense, right? It makes sense to think so. Here is why. It makes sense to think so. We know that this part is 90 degrees, right? So any angle lower than 90 degrees will be here or maybe there or there. These are angles that are lower than 90 degrees. But our angle, our angle is really big. Our angle is all of this, right? This is the theta, is all of this. So we know it's bigger than 90. We know it's bigger than 90. All right. If we follow that idea, we know that this is 180. So our angle cannot be lower than 180 because it would have to be here or there, right? Right? And our angle is bigger than that. So it's bigger than 180. We also know that all of this part is exactly 270.
270.
Pretty good, Danny. And simply because the line is before 270 and after 180, we know the angle has to be between 180 and 270. So I will say the approximation of 200, 240, 250, that approximation is correct. It's a good approximation. You guys did it correct. Beautiful. Pretty good, guys. Now that we have guessed, approximate, estimate the angle, now let's use the formula. All right? Go ahead and write this in their calculators, guys, and tell me how much is this. Tangent to the -1 of y over x, right? Remember, y equals negative square root of 3, and y equals -1, right? Put it in the calculator and tell me how much is that, please. What happened there? All right. Thank you, guys. Look, you don't learn math by looking at your teacher or by looking at the screen. You learn math by taking the calculator and doing the things. You learn math by doing the exercise, by practicing, by making mistakes. So thank you to all the people who are writing in the chat the answer. Thank you, guys. Thank you. Now, a couple of issues. What? A lot of you, I don't know, like 10 of you said the answer is 60. And that is partially correct. Partially. Because the answer is 60 degrees. Remember, if you don't write the units, if you don't say these are degrees, then you are saying these are radians. And that will be a mistake. These are not 60 radians, right? These are 60 degrees. Two people got it correctly, though. 60 degrees. Yes, if we put this in a calculator, this is 60 degrees. But is this angle 60 degrees? We said it at the beginning. We said it. We said the angle theta should be more than 180 and lower than 270. Around 200. This angle should be around 200. So why is this giving us 60 degrees? Why? Man, this is why you should not trust formulas and calculators. This is why. Because when we use the formula, this formula has a mistake. This is clearly a mistake. The point lies in quadrant 3, which makes it that we need to make a correction to the formula. This is the correction. We need to add 180 to the formula. Go ahead and write it down, please. Because you guys are going to forget. I know you're going to forget. In today's exercises, you are just going to use the formula without the correction. You're going to have mistakes. And then the quiz is going to come. The workshop is going to come. Huh? Write this down. Don't just write the formula. Don't be lazy. Write everything. We need to make a correction because the angle is in quadrant 3. The point is in quadrant 3. Danny, did you copy? Danny.
Teacher,
Yes.
but what's the problem with that it's in quadrant 3? I don't understand that part.
A ver, bueno, paso un momentico al español. No sé si de pronto con esto lo puedo explicar bien, pero tal vez no. A ver. Esto es GeoGebra, ¿listo? Esto es GeoGebra. Entonces, mira. Uno puede escribir tangente y le grafican a uno la tangente, ¿sí? Entonces, mira,
Sí.
así sería más o menos la tangente, ¿sí? Esta es la función tangente. ¿Sí sabían esto? ¿Sí lo habían hecho o no lo habían hecho nunca? Puedo dibujar tangente, puedo dibujar el seno de X. Mira, así es el seno, mira. Seno, el coseno de X. Así es el coseno de X, ¿sí? Mira, seno, coseno y tangente, todas tres. Bueno, uno puede graficar eso, ¿sí? Pero también, así como podemos graficar esta, podemos graficar las inversas. Entonces, mira, podemos copiar arc tangent, arco tangente de X, mira. Y la embarré. Borrar. Arc tan X. Ahí está la función. Esta es la función arco tangente de X. La que estamos usando, tangente a la menos 1. Esa es la de nuestra fórmula. La de acá. Tangente a la menos 1. Es esta. Se ve así. Y esta función tiene un problema. Esta función está entre pi y negativo pi. Mira, si yo me alejo, esta función se acerca mucho, mucho al 2, pero en realidad nunca lo va a tocar. Mira, mira, mira. Hay unos valores que la función nunca va a tocar en y. Esos son valores de error. Entonces, mira, esta función está entre pi. Voy a ver si puedo escribir pi. Y igual pi. Medios. Ay, no funcionó. ¿Qué pasó? Y igual pi. Medios. Ahí está, ahora sí. La línea naranjadita se acerca al azul, ¿sí? Pero esto tiene un problema. Cualquier número mayor que pi va a traer un error. No hay un número en X que dé mayor que pi.
Profe, hasta ahora lo he visto como cualquier otra gráfica en un plano cartesiano. Sigo sin entender qué está mal.
Ok, bueno, pues allá voy. Esa es como la mejor forma de entenderlo. Honestamente creo que no hay otra. Esto de aquí son valorcitos en X y Y. Cada uno de estos valores en X me da uno en Y. Cada vez que tú, por ejemplo, mira, cuando X vale 10, Y vale, bueno, por aquí alguna cosa. Mira, muy cercano a pi medios, muy cercano a 1 punto algo, ¿sí? Cuando X vale, cuando X vale 24, pues Y vale otra cosa. Cuando X vale 2, mira, Y vale otra cosa. Cuando X vale 0, así. Pero no hay un valor, no existe un valor para el cual Y valga 4. No existe. ¿Estás viendo, Dani? Mira la gráfica. ¿Cuál es el valor de X para el cual Y vale 4? Pues no existe. Porque la función no pasa por 4. No pasa. ¿Cuál es el valor de X para el cual la función vale 6? O 2. O 5 aquí en el medio. No existe porque la función no pasa por ahí. Si la función pasase, por ejemplo, si yo tuviese esto. Aquí un recorte. Si la función pasase por rojo, por 4. Por ejemplo, si mi función hiciese esto. ¿Estás viendo, Dani?
Sí, pero sigo sin
mira.
entender entonces qué relación tiene esto con los 60 grados que sacamos hace unos...
Bueno, pues para allá voy. En este caso, mira, aquí sí 4 sí habría un valor para el cual X, para el cual Y vale 4. Este de acá 3 punto algo, o 2 punto algo, no sé. Ahí sí existiría. Y eso trae un problema, porque es que estamos buscando ángulos. En este ejemplo, acá, este ángulo es de 200 y algo. Es claramente mayor que pi si lo pasas a radianes, Dani. O sea, esto es más que 3 punto algo. O sea, estamos buscando un valor de X para el cual Y debe valer 3 punto algo. Ahí está la relación. Porque ahora es como si estuviéramos buscando este valor, aquí, cuando Y vale 3 punto algo, por aquí. Y no hay un valor de X, la función no pasa por ahí, no existe. Por eso la función nos devuelve un error. Porque no existe ese valor. No existe un valor de X para el cual Y valga más de pi. Y ese es el ángulo que tenemos acá. Aquí tenemos un ángulo más de pi. Bueno, más de pi. 3 punto alguna cosa, más de pi. Eso es en radianes, claro. Estamos hablando de 240, 220, 200, 250 en degrees. Pero en radianes ese valor es 3 punto algo. Tal vez 4. Y no existe ese valor en la función. Esta función es perfecta entre esta línea azul y la de aquí abajo, la negativa. Y igual negativo pi sobre 2. Esta función es perfecta entre las dos líneas, la línea azul y la línea gris. Aquí no hay errores, mira, por los positivos y por aquí abajo por los negativos tampoco. Pero si yo busco un número mayor que esa linecita azul y esa línea gris, me va a dar errores. Cuando busco ángulos muy grandes como este, pues este ángulo en radianes es un número muy grande. 3 punto algo, 2 punto algo. La función tangente inversa no nos funciona por esa razón. Porque el ángulo es muy grande. Ahí es cuando le damos la corrección. ¿Okay? Yo sé que de pronto es un poquito loco esto. O sea, ay, pero no entiendo. ¿Cómo así que tiene que ver esto? O sea, esto es un plano, pero es que no entiendo. Yo sé que de pronto puede ser loco, pero honestamente esta es la única justificación que puedo dar. Esa es la razón.
Ay, bueno, pues no entendí nada al final, profe. No entendí
Ok.
qué relación hay en los 60 grados que sacamos con esta corrección.
Ok, si algo más despacito lo vemos y ya miramos a ver cómo, pues, no sé, más despacito en una tutorial, algo así lo miramos. ¿Listo? Let's continue with this exercise. All right, take a look at this. 60 degrees will be around here. This will be 60 degrees. So we are clearly not looking for 60 degrees. We are clearly looking for this one. This is 60 degrees. How much do I need to add to get to this whole line? Okay, so we need to add this part. Right? If to the red I add the blue, then I reach the whole theta, right? And how much is the blue? Well, the blue is 180. Simply because this makes a line. This whole makes a line. So we add 180. This is the reason why we need to add 180 precisely. Why we don't add something else.
I understand.
Now you got it? Okay, cool. Now you got it. So the problem comes because the number is too big. How do we fix it? We add 180. Why do we add 180? Because the angle is too small, and that is exactly what we need to reach to the other point. Okay? So now, if we do the process again, 180 plus tangent, whatever. If we do the whole process again, we get 180 plus 60 degrees, which is exactly 240. This angle theta was 240. Now we can change these to radians. We can change these to radians. That is something you can do. If you want to do that, that is okay. Now, I don't think it's 1.05 radians, Stefan. I think there is a mistake there. because this angle is bigger than pi, and pi is 3.14, right? 3.14. So this should be bigger than 3. Should be bigger than 3. All right? Whatever. We have the angle now in degrees, 240. 240. How do we put it as an answer? Here. We have the r equals 2, theta equals 240. So this is the answer. Parenthesis 2, 240 parentheses. That's it. That is the answer. The only difficulty here was that we need to remember about the correction. About the correction. All right, formulas per quadrant. Quadrant 1. When a point is in quadrant 1, here are the two formulas. The distance, r, is found like this. That's it. Is the usual distance. We don't need to change nothing here. And the angle theta, since it's an angle that is really small, we don't have to add a correction. What about the angle when the point is in quadrant 2? Here, in quadrant 2, a point in quadrant 2. This is quadrant 2. These are the formulas. Our distance is the same. Look at that. R equals x squared plus y squared. And then the root. We have the same formula for distance here. But the angle now, we do have to make a correction. We do have to make a correction. The correction is 180 degrees. Salome, give me just 1 second, right? For quadrant 3, the angle is too big. The angle is too big. Again, these are the formulas. Formulas for radius is the same. This is the same radius, the same than this, the same than that. It's the same. Radius doesn't change. But we do have to change the angle. Again, we add 180. We add 180 because of the correction. And last, when the point is in quadrant 4, here, quadrant 1, 2, 3, and 4. When the point is in quadrant 4, how are the formulas? Same formula for distance and same formula for degrees. Look, same than the first. We do not add 180. We don't have to correct anything here. The angle is pretty small, so everything is going to work just fine. Remember, when the angle is too big, we need to add 180. So in quadrant 2 and quadrant 3, this is the reason why I told you you need to plot the point first, because you want to know where the point is located. Is the point in quadrant 1 or quadrant 2 or quadrant 3 or quadrant 4? Knowing where the point is located is going to tell you if you need to make a correction or not. So you do have to plot the point first. You do have to plot the point first. And you're going to make corrections for quadrant 2 and quadrant 3. Now, for people who like to take screenshots, take a screenshot of this one right now, because this one includes the formulas for everything. All right? Cool. Salome, tell me your question, please.
Profe, ya está respondida. Era que cuando utilizaba el 180, pero ya con lo de los cuadrantes me quedó más claro. Gracias.
Okay. Cool, Salome. Cool. All right, guys. From here, we're going to get to work, right? We have to practice. In mathematics, we don't learn by looking at the teacher. We learn by practicing. So get to work on these exercises. Page 726, exercises 55 to 66. 726, that is the page. These exercises, 55 to 66. I have it here. Page 726, these exercises from 55 to 66. Read the question. Otherwise, you are not going to know what to do. Read the question. All right, I'm going to stop the recording now. And remember, if you have any questions, I am here for you guys. All you have to do is ask.